Hello, I'm Roman. Welcome back to a series of the videos of building the convolutional neural networks from the scratch. And as you saw, the last 3 or 4 videos were in this ASMR style, where I just focused on writing the code again from the scratch, because I actually I started to implement convolutional layers and I got messed up. So then I spent some time to re-evaluate how I'm going to build this, and I draw this diagram, which something like this. So I used the video about building the convolutional neural networks and I had some notes. So basically I focused on building the convolution itself and do not go with, for example, the max pooling or any other type of the layers. So I will try to use it, and that's it. And meanwhile, in between videos, I actually kind of started to test it a little bit, but I prepared the code and we'll see the results. I actually spot a couple of issues, small issues. For example, the kernel shape was not initialized properly and other things. But actually, with this video, I will write the marshaling of the convolution layer, because that's what I forgot to do. Because if we take a look at the main, actually replaced, and right now we have the run fashion CNN model, and currently it's a copy of training of the model based on the MNIST dataset. But here I decided to, I'm not sure about this one. Okay, but all of them should have some sort of the activation. But there is a big difference. Right now we have the CNN layer, which is the convolutional convolution layer, and then we have set of the dense layers, but basically the same as I had before. I'm not 100% sure that should be that I should have 3 dense layers after the convolution, but we'll see. I also think we will need more epochs, and I'm not sure about the optimizer actually, because what I've seen previously, it was new SDG, stochastic gradient descent, but it doesn't work well with the sensors. Okay, so let's leave it as it is right now. But the main thing what I'm actually doing is I do the training, then I do evaluation, and then we store the data in the file, and then I need to retrieve it, load, and do evaluation again. So for example, the model is saved correctly, and there is one thing that is missing in the marshaling. For example, before I had to store the dense layer and actually storing the dense itself and then the layer, and we have the methods like marshal and marshal JSON, those two, right? And then, for example, where it's used, if we take a look where it's used, actually it's used in the data model provider. We have two load and save. I think this one, save, no, store, right? This one. And this is where we check, right? If it's a type of the specific one, then we store it. So for example, for the layer, we have this layer wrapper, and I'm going to have the same for the convolution. That should be here, convolution layer going to be something like this. Convolution declared, but it's not used, right? And then we do something like this. So if the type of the item is the convolution, then we using we downcastle it to the convolution. Then we using the convolution wrapper. Well, currently it's empty, right? That's how it is. And then I'll declare but not used. That should be like this. And then convolution wrapper, I think I will pass the convolution layer, which is the layer of the flow. Okay, and then we pass in the convolution layer, and that's it. And that should be the same as storing it. As for the loading, we have to do the opposite, right? Where we have decode. If the layer data type equals to convolution, right? Then we decode. Also for this one, we have, for example, something like this. Right? Convolution wrapper data, that's what we store in the JSON. Could not import. Why? Model marshaling. Something weird. Could not use. Wait. Unkeyed fields. How it looks like this. Okay, this is how it will work with the marshaling. And I mean, if you're thinking that I'm, talking very weird and cannot grab all of my thoughts into normal stream of saying, that's because I'm sleeping way less than I should sleep. So how we keep telling it is what it is. But I'm still trying to, do this and progress, at least in the baby steps. Well, it's funny because of the baby steps. Yeah, we need actually something like this, so we will need layer wrap. Same here, that should be marshaling but convolution wrapper. Then we going to kinda well, basically marshal L. What is L? Okay. If equal to name, then right. And then we're doing it once again. So we actually unmarshal the layer wrap. Yeah, we kind of marshalling and unmarshalling back and forth, so I can, at first I kind of typecast it into this thing, then I check some attributes via the map, and then once I get what I needed, actually marshal it back into the JSON. I marshal it back into the slice of the bytes, and then I'm using unmarshal that will use this method to actually unmarshal and fill the data. Once we have, then we can do the layer actually, and we could have the convolution, and I guess then it should be add layer, and here I need to load from params, something like this, which is kind of the same as we have here. So in a dense layer, I need to store the weights, the biases, L1 and L2 regulator. For the convolution, what are the things I want to store? I want to store the input shape. I don't want to store inputs. I want to store depth. I want to store kernel size. No, actually, no, I don't want to store the input shape, because it's the shape that is defined. Well, no, I want to store the input shape. I don't want to store the inputs. I want to store depth, kernel size, and the output shape, right? And the kernel shape, and kernels, and the biases. But actually, that's all what I want to store, right? This one, then this load from param. Okay. So here I would runs, right, and basically just Python some data. So I'll have the input shape, depth, linked. What else? Kernel size, kernel size. Wait. Shape, depth, kernel size, which is int. Right. Output shape and the kernel shape. is output shape. Oh, it's input shape. Right. Like this. So we have the biases. Oh no. Yeah. Like this and this. No. So we can go. So we have the input shape. Right. There. Kernel. Can just kernel shape or of type input shape as the kernel shape. Alright. Kernel shape. So that's basically it. Params. We'll see that. I hope I did not forget anything, but let's go. Which means that here I will need to do something like load from params. And that's all the things I need to have in the wrapper, right? I think I'm okay to annotate the input shape and the output shape. With some annotations. For example, here it will be depth, right? Here, right? And here. Then same for the kernel shape. Depth, input depth, right, and okay, which means that okay, I don't need this. Oh, how it's telescope commands, buffer line, close others. Okay. No. This one. So it means that I need to have several things. I need to have depths, yes, and you can get depths, right? House. Have the input shape as layer, input shape, right, and this is input shape. Okay. Then we have the output. Then we have kernel. Loads. Kernel size, int. Okay, and then I need to store actually this one, which is how I did this in tense. Again, this one, right? Okay, and how I store this? Interesting, will it store, like if I will declare now something like kernels as to the array of dense wrapper and then attribute it with the JSON kernels, and then do the same but for biases, will it work? Okay, so I need to, layer data. Oh, this is what actually I need to do. Okay, what it means? It means that I will have the kernels as I'll make, and that should be dense wrapper by len. Okay, for my Okay, then I should have the same for the biases, although it will be smaller, just one-dimensional array. Again, dense wrapper value biases, right? And then len, actually for biases equal to dense wrapper dense, and we have value. I hope it's smart enough to decode array. But I will see. Okay, then what I'm doing right now. So I have the layer data, which is the convolution of this one, right? And here we go. So we have, for example, depths, which is value depths. Okay, input shape. Again, and right now we have the kernels, which is this one that we created before. Same we have for the biases and same as before. Okay, then what we're doing, we're actually copying this one. Have value of convolutional layer. Then we have reflect. Okay, and JSON because it's encoding. Okay, it should work, but let's see. In order to test it, I'm going to run the training, and I will run it for, I don't know, where's the one epoch. Yeah, you can already guess what will happen. Go run. I mean, it should panic once. Oh, it's actually started to go down. I mean, the accuracy. Nice. Okay. Yeah, this is something that I will need to... Oh no, going up again. This is something that I'm going to debug later. Wait, why going for the second debug? Enrolled. Okay, let's do 1 second. And actually, where this one? We need to wait for a while. And then what I want to check is that it marshaled the array properly. Because if not, then I need to deal with this manually. And then we're going to write a marshaling, right? Which is kind of the same as here. I mean, I can already start to Interesting that from okay. Okay. Evaluation expected input size with input shape. Okay, seems valid. The question is, or actually I have bits. I can GQ. Oh no, this one, right? CNN. That should do the trick. Where this one? Yeah, this one. Okay, so we have. Okay, we have layers. We have the convolutional layer. We have the depths. We have defined the input shape, the output shape, and kernel shape is incorrect. Okay, that's the first thing. Where is this one? Kernel. Oh, kernel shape. Okay, kernel shape. Okay. But that's, I mean, I will have to. Then we have the kernel side, then we have kernels. Wait, I have the kernels array. Inside I have another array with one element. I mean, I have two kernels for the grayscale, so it should be actually two kernels, right? With side 3 by 3, so we have 3, 3. Okay, so it's actually seems working, and I have biases, which is a very long list because it corresponds to the number of the input, which should be a lot, right? Oh, okay, so that's pretty big file. Okay, let me do this. This one's incorrect, and this one too. So, on marshaling, what I have here, okay. Dense. No. Layer. Okay. So we have L. So it should. Okay. How to wrap. Wait. No. L, for example. Okay, what we have? Depth. Okay. L depth equals to route data depths. Okay. With dances, it's going to be interesting, right? I will try to write a macro. No. Okay, failed, but okay. Wrap data, this one, then I have what else? Okay, and there are two things I need to copy is, I mean I need to move is, it's actually value, okay, value convolutional layer equals to L and return new. Oh, that's on marshaling, yeah, because it's then what I'm doing, I need to do this value, no, value biases equals to make, and what's this, the size? Where we get the size? We get from data biases, right? Okay, button define. Okay, go, no, right, no, and how is it met? We have value biases. Grab data biases and like this, right? Then I should do the same for the weights, well, for the kernels. That seems correct. What I'm going to do right now, let me check. So, if I did everything correct, then if we check this one, then it should store the model again into the JSON, then load it and run the evaluate, and it should not have some sort of the panic or any other runtime issues. Most likely the architecture of the model is something weird, because if you can see that the data loss is actually, well, it's not changing at all. Accuracy is jumping back and forth. I mean, why are you going to the next epoch? Okay, never mind. I will wait. It's not increasing much, but the main thing that the loss is more or less the same. Okay, evaluation. The accuracy is 10%. Oh, we have the convolution, reload, dense, softmax, Adam optimizer, evaluation, and expected input size. Okay, so actually unexpected input size from the input shape. Okay, so I messed up, and I know what is missing actually, and the missing part is here. Wait, not here. Here, and here, not here. Model data provider. We should have in the load, we should have a call. This one, right? That should be layer load from params. And where we get them? Right, in the layer wrap. So what goes first? We have the input shape, input, wait, layer wrap, input shape, depth, kernel size, kernels, output shape. What else? Kernel shape. Kernels. Layer wrap, kernels, and biases. Okay, let's test it again. Unexpected length of biases 0 with output. Really? Okay, the only thing, it's probably because here, right? Okay, let's try it. Okay, well, it will take some time. Can I quickly have the validation data? Model. Let's validation data model. Okay, is model. Then I have the validation, which is this one. X1. And batch size. What's this? Always forget this convention. Come on. what's the error? Fails to get layers. Oh, well, okay. 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 And another thing that probably I need to check, that training with dense layers only still works, that I didn't break it accidentally. And yeah, but probably that's the topic for the next video, is actually understand what is missing. For some reasons, I guess the biases are not loaded properly from the JSON, so that's the topic to dive into. Once it's fixed, I will actually try to replicate I'll try to replicate the same architecture from the video, so it's basically one convolution, one dense layer, etc. But there are things, and we have biases actually, so for some reasons they are not loaded, which means that I can go and do this, right? Should I do this? Okay. For example, okay, we have the layer data. Okay, we're checking for the type. That should be this one. Okay, then so we have the graph, we have the data. Okay, we have tense wrapper. Value, we have the convolution, but biases are empty. Wait. Because this. This and this. Once again. Okay. The results itself are really bad. The accuracy is super slow or super low, meaning that it just doesn't work. It actually means that the convolution is not working. 10% means that I have 10 categories, which means that I have a 10% result and 10% accuracy of the results, which most likely just filled with the same numbers. And this is how you get 10% of accuracy. which is, I mean, I will take a look at the data. I mean, I will take a look at the numbers in the model. And in the next video, I will actually try to replicate a different architecture with less and simpler version of it, the one that we had in the one that I had in the video. I will open it and take a look, and that's it. But for now, thank you for watching, and I see you in the next video. Bye bye.